All right, hello class. Okay, so we're going to do this conservation of momentum lab by studying collisions. So there's several parts to this lab, but part one is a perfectly inelastic collision when the carts, we're going to collide two carts. We have one sitting here and we cause a collision, and we want to measure the velocity before and after the collision using photo gates. So we've got those here. And so let's think about what we're trying to do. We want to measure the velocity before and after the collision. And so we only need one photo gate for this one, because, or one beam blocker for this one, because they're going to stick together and move as a combined mass after the collision. And obviously friction is a factor here, which we neglect in our experiment. So it's very important to be careful about the how we set up the photo gates. I guess this will work. So yeah, the idea, they've got Velcro on them, so they'll stick together. And we want to measure the velocity right before and right after the collision. So if you remember how the photo gate works, I set the height so it's reading the top beam here. And obviously the faster it's going, the shorter time period that beam is going to block the laser, so the computer can easily figure out the time. And so to kind of optimize this, where we remove friction, we have to be careful how we set up our carts and how we set up the photo gates. So let's just leave this one fixed, the first one. So I'm going to lock this in place. So the cart's going to go through, and right here, it's easy to see. You can see where the laser beam is. Like right here, the first cart has passed through the photo gate. So when we do the experiment, it's going to read the velocity right here, and then of course the cart will slow down by friction. So we want the collision to occur right after this point. So I'm going to put the second cart here. So now we go through, it's going to read the velocity, then they're going to collide. And now I want to read the velocity right afterwards. So I'm going to put the second photo gate right here. So basically right here we read the velocity, then there's a collision, and then immediately it's going to go through the second photo gate. And so we can get this V and V prime just by setting it up like this. And we're going to do a few trials here, so we'll look at the details again. So in trial one, let's see. Okay, we leveled the track. So we're going to push a lighter cart into a heavier cart. So I'm going to put this mass on the second one. We're going to push a light object into a heavy object. So I set it up here and just do that. So we get the velocity right before and right after the collision. And what's nice about this lab, if you're not doing it in person, is there's no graphs involved. The computer output is just going to be a velocity for each photo gate. So the first one, photo gate 1 is V, second one is V prime. We've got the masses of each cart. We added one. So that's trial 1. And trial 2, we're going to push a heavier cart into the lighter cart. So I can see it reads velocity here. So trial 2 is going to be like this. So we push a heavy cart into first we push a light cart into a heavy cart, now a heavy cart into a light cart, and then finally we just remove the mass, and trial 3 will be this. Okay, so that's it for part A. We looked at 3 perfectly inelastic collisions. And again, I'm just going to give you the data. It's just numbers. There's no graphs, which makes things a little bit easier. Now the next one is a perfectly inelastic collision. So there's magnets in these carts. So if I push one into the other, you can see that they're going to bounce off each other without actually touching. And so this is as long as they don't touch, this will be an elastic collision. So we want to explore those. Okay, notice they're equal masses, and so like one's at rest. Notice one stops and the other one moves. They just trade velocities. Yeah, we talked about that in class, so now we can see it in action here. Put a mass on, that same thing won't work. And so, yeah, let's look at the details here. We're going to do 2 trials for this one. So to start out, we're going to push the slower cart into a larger cart. And so this is a light object hitting a heavy object. We'd expect the light object to bounce off. So we're going to expect the light one to come in and then bounce off. And the heavier one's just going to move away from, the direction it was hit. So let's try it just to see. Yeah, so this one bounced off, this one moved to the right. And so again, the real key to this experiment is setting things up properly. So what we want to do, we're going to push the light cart into the heavy cart, and the light cart is going to bounce off. This is the trial, the experiment, where friction is the most significant. So let's think about, say the photo gates were set up properly. So we're going to measure the velocity right before the collision, and then when it bounces off, we'll get the velocity right after. We also want the velocity of this cart, as it was at rest, after it gets kind of hit, although it's not actually touched, it's going to move away. So we're going to want, this is going to be V1, just that. Okay, here, this is V1, this is V1 prime. And when it gets hit, that's V2 prime. So we've got V1, V1 prime, and V2 prime. V2 is 0, so we don't have to worry about that. And so let's just look, I'm going to move this photo gate out of the way. Let's look at this one. We're going to get V1 here, and then it's going to bounce back and go through the photo gate again. So this photo gate is going to give us 2 readings. The first one is the cart moving to the right. Second one is the cart moving to the left. And the photo gate has no idea what direction that cart's moving. So you have to know that this velocity is positive, the one going back is negative. And so, yeah, we're going to get 2 readings from this photo gate. And then we'll set up, so when this one gets hit, well, the photo gate, it's going to go through, that's going to be V2 prime. So we get 2 readings from this one, 1 from this one. And it's really important, let's set cart 2 right here. So cart 1 hits, the collision occurs right around here when they're this far apart. So we're going to need photo gates on each one for this. So I'm going to just put the cart here at this fixed location. It's at 40 centimeters. So the photo gate would go here, so as soon as this cart gets hit, we're going to read the velocity. So friction won't be much of a factor for this one. And this one, they start to interact right about here. So they interact here, so I want to read the velocity. So the carts have to be the gates have to be much farther apart than this. So like here, we're going to read the velocity, then they're going to collide, and then this one's going to go back the other direction to give the second reading. So let's test this. And again, if you push it too fast, they're going to collide, and then you have to redo it. So let me just try this, see how well it works. Okay, that actually worked fairly well. You notice the second cart stopped though, because friction does play a role. So let's do that and just look at this again. Yeah, it wasn't slowing down too much on the way back, so I think that was a good trial. Let's just watch that one more time. So as soon as this one gets hit, it's going to read the velocity. So here, let's watch this one. So we read the velocity once, and then twice. Might have slowed down a little bit, but that's actually good news. That gives you something to talk about for errors, friction. Okay, so that's it for part 2. Oh no, that's not it. The second thing we're going to do is we're going to push a heavier mass into a lighter mass. So here, let's watch what happens here. We're going to read the velocity. They're going to collide. Okay, this one is a bit of a problem, the way I set up the track, because one end is right here with a bumper. So when the heavier one hits the lighter one, it's going to keep on moving. So to get V1, this is V1 here. To get V1 prime, now we're going to get two readings on the second photo gate. So like here, we're going to get the first reading on photo gate 1. That's V1. And then it's going to hit and knock this cart through the photo gate. So that's going to be V2 prime. And then this is going to be V1 prime because it keeps going. I'm going to try and do this. Now the problem is I put the bumper right here, which is not ideal. So what I'm going to try to do, I'll see if I can time this. As soon as cart 1 passes through, I'm going to try and just pull it out of the way so it doesn't interfere with this one. So let's see if this works. Okay, that actually worked. So if you're kind of going in slow motion, we read the velocity of the first cart before the collision, and then they collide. This cart goes through the photo gate, and then this one kept on going and also went through the photo gate. And so, yeah, first trial, we push a light mass into a heavy mass where it bounces off. This one, we push a heavy mass into a lighter mass, and so they both go through. So we'll get, just like before, we'll get 3 readings, but 1 in this photo gate, 2 in the other. And now, it's actually made a little easier for you because I'm just giving you the data in like a table form. So I'm kind of explaining, you have to be able to know, like this is photo gate 1, what that one reading represents, and for photo gate 2, you'd be looking on the computer screen and see 2 numbers there. You have to understand that the first one is the first thing it read, which is V2 prime, and then this cart went through and that was V1 prime. So, but again, it'll actually be a little bit easier for you because I'm just giving you the data in a table form instead of like what the computer screen would read. Now the last one, we have a spring inside this cart. And so I set up the photo gate so as soon as, like, let's say this cart moves, it's going to pass through the photo gate immediately. So again, friction is going to be negligible in this case. So this is going to push through, and this is going to read the velocity. Well, right now, nothing is moving. So we have V1 and V2 are both 0. And so I'm going to push this trigger, which will release the spring and separate the carts. And I'd prefer to have something to push the trigger down, something less frictiony than just like using your finger, because like if you push it and you're still holding it, that's going to slow down this cart. So yeah, like a little metal thing to push it would be a little better. Maybe a pen will work. See one right here. Okay, so I'm going to push it and they're going to move away. And again, the key to this is just setting up the photo gates properly so that they don't slow down. We want to know what happens right after the collision. So let me push this and just get out of the way. And they went in opposite directions. And we're going to do 2 trials there. Trial 1, we're going to put, so we're going to put 1 mass. Okay, that was actually right. Let's do this experiment again. I think I had the photo gate set up wrong. Anyways, this one should have been here. Yeah. Oh no, it was fine. They just the plunger kept them farther apart. Okay, so this cart has the mass bar on top of it. So what we should expect is this cart's going to kind of launch this way. This one's going to move more slowly because it's more massive. So let's watch this again. So we should, and again, we're going to read the velocities right after the collision. So I'm going to trigger it, and yeah, this one should fly off. This one will just kind of move more slowly. Hard to tell, but you'll see in the data, one moves faster than the other. And then we're going to remove the mass and do it again. And this time they should both be going the same velocity away from each other. And so that's basically it for the conservation of momentum lab. Took about 15 minutes to do. But of course, in lab it usually takes a full 2 hours because, well, I didn't do any of the electronics. These photo gates don't have anything plugged into them. I'm just going to use data from a previous lab. And yeah, and I know this lab, so if you're doing it for the first time, you have to really think about what you're doing. So, yeah, we've got the video so you can actually see things. Oh yeah, one more thing. One of the questions in this last part is how much potential energy was stored in the spring? So like right now the spring is compressed, and the question is how much potential energy is there? And students always ask me, what is the force constant of the spring? And I have no idea what it is. You don't need to know what it is. So we know the potential energy of a spring is 1/2 kx squared. We can probably estimate x by just the length of the plunger. It's probably about how far the spring moved. Not sure exactly, but probably about that. Yeah, I'm feeling resistance as soon as I push inwards. So the spring, yeah, the extension is, maybe 3 centimeters or so. But K, we have no idea what that is. So that's not the right approach. The potential energy of the spring, you don't want to think 1/2 kx squared. I don't want to give it away, but forget about that. That's a good start. There's another way to find the potential energy of the spring, and try to figure it out. If you can't, well, then ask, and I'll help as little as I can until you get there. But, all right, so that's it for this conservation of momentum lab. And yeah, I'll give you the data in a table form, but it's good to actually see things. This is pretty much the entire lab, except it wasn't wired up to the computer to get the actual data. But all those trials would have worked just fine.